Hello there and then welcome to a brand new video. I do hope you are doing well. Now in this lesson, which is the first of the playlist, we are looking at the radical expressions, and specifically we are looking at sets. Now this is a term that is used for a particular type of radical expressions. So this being the first video, we'll cover the precise terminologies and then understand why some radicals are called sets. And then we'll learn some fundamental rules to simplify them as well. So without much ado, let's quickly look into it. So we say this symbol here is what we call the what? The radical sign. And what is this radical sign used for? As you can see clearly, it is used to ask for the root of a number. Okay, it is used to ask for a root of a number. Now it is important to take note that every radical expression has three components. It has three components. The very first one is the index. The index. Now, the index is what we actually put over here. So let me just put that here. So N for index. Now, the index is the very small number that specifies the root. You see, so talking of root, then I mean, are you trying to work for square root, the cube root, or the fourth root, the fifth root, what have you? So that most of the times, if you see a number such as 4, and then you see it this way, it means you are looking for the square root of 4. That is how we call it. Then if you have something like this, you are looking for the cube root of 8. You get it? So the index here determines the root that we are actually looking for or we want to solve. Now, most radical signs are not written with the index. And whenever you see a radical sign written without the index, such as this, we just consider it to be the square root, meaning there is actually a 2 over here. So for the square root, we don't write the 2. Okay. Apart from 2, any other index, you try as much as possible to put it there to indicate. So the first thing we need to take note of is the index. Now that we know the index, the next thing in a radical expression is the radicand. The radicand. Now the radicand is the number or expression inside the radical symbol, right? So in this case, I'm going to put an X over there, right? So let's put an X there. And we are saying it is our radicand. Once again, the radicand is the expression inside the radical sign. So for instance, just as I've written, if you have the square root of 4, then our radicand is what? 4. And our index, as I said, if it is not written, then it is 2 over here. Okay. Then the last thing that a radical expression can contain is what we call the coefficient. The coefficient. The coefficient, just as in algebra, coefficient is the number that is multiplying the radical expression. And it is mostly written outside. So if I have 5, then square root of what? Let's say 4. Then what I actually mean is 5 times the square root of 4. Now, it is important not to mistake your coefficient for your index, so that if you see something like this, then you think this is your coefficient. Hence, you need to take time and then write it clearly so that you would specify or be able to tell if it is either an index or a coefficient. So the coefficient should be in the same line as your radical sign. You see, they are in the same line. Anything apart from that makes it an index and not your coefficient. So that if I write it this way, someone might consider this to be an index. Meanwhile, you actually meant for it to be down here so that it becomes a coefficient. So these are what you need to know for what? Radical expressions. Now, there's one other thing we need to take note before we actually go into the topic. So what is a surd and then what is a perfect root? Others call it a perfect square. Okay. So on top of a perfect square, for instance, if I have the square root of 9, as we have said earlier on, if there is no number here, then it simply means it is 2. What this is actually asking for is that what number multiplies itself to give us 9? What number multiplies itself twice to give us what? 9. And that is 3. You see? Then if we have the cube root of 8, it simply means what number multiplies itself thrice to give us 8. And that is 2 times 2 times 2. 2 times 2 times 2 gives us what? An 8. So the number that will multiply itself 3 times to give us 8 is 2. You see that? And what of the fourth root of 81? It means what number multiplies itself 4 times to give us 81? We have 3 times 3 times 3 times 3. 3 times 3 gives us a 9. 9 times 3 gives us a 27. And 27 times 3 gives us an 81. So we can say that the number that multiplies itself 4 times to give us 81 is what? Our 3. Now, all these that we are actually solving for, they are giving us answers that are rational. They are giving us answers that are what? Rational. We call them perfect roots. You see? So, as we are looking for their roots, they are giving us what? Rational numbers. Hence, we call them what? Perfect root. On the other hand, if we take numbers such as the square root of 2, we are asking ourselves what number multiplies itself to give us what? 2. You see, what number multiplies itself to give us 2? There is no counting number, there is no rational number, but rather we get an irrational number, which is 1.414. It goes on and on and on, right? You can take a calculator and even evaluate that. It goes on and on and on. That is 1.414213562, and then it goes on. That number is not a rational number. You see, it is not a rational number. We say irrational numbers are those that cannot be written as what? Fractions. Its value does not terminate, and then it is a non-repeating decimal. Also, if we take the square root of 10, we have 3.162, and it goes on and on and on. These ones here, when evaluated, do not give us counting numbers. And that is what we call what? A surd. So a surd is simply a radical expression that cannot be simplified into a rational number. Its value is non-terminating or non-repeating decimal. And hence they are what? Irrational roots. So take note of the difference between surds and the perfect roots. If you evaluate a surd expression, the root you get is not a rational number. But for perfect roots, you would get rational numbers. This being the introduction or the introductory video, I would end here. And you can check in the playlist so we continue the lesson where we look at how to simplify sets. See you Stay blessed.